So we are, to give you a sense of what's happening today, we're going to start with math, and then we're going to go into some science. So let's talk about math. All right, math is 60 minutes long. It has 60 questions. We could do a little bit of a warm-up math exercise here. I could ask you something like, on average, how many minutes do you get per math question? By the way, if I ask that and you're all putting your answer in the chat, guarantee we probably won't see all those chats go through. But in some ways, it's not a very good way to think about average per question, because we know that some questions are going to be relatively quick and easy, and some questions are going to take you longer. So there's absolutely no reason to try to kind of stick to the same amount of time per question. What you really want to do instead is do the easier for you questions first, right? And so the easier for you questions first, and then those questions that are doable but time consuming, right? You do those second, and then save the ones that you're just like, I don't know, or oh, I could really, maybe figure it out. Do those last. And that's really how you should prioritize your time, rather than trying to do everything in. There, I saw it in the chat, right? And that was only just like a small smidgen of you that had responded to that, rather than trying to do everything in, as Neil points out, the loneliest number. All right, let's take a look at some of these questions. All right, now you do have polls open and available for this. So rather than putting your answer in the chat, I would prefer you to either like hold on to your answer and be like, oh, I personally know whether I got it right or wrong. Or you can, of course, put your answer in the poll if you absolutely must put your answer somewhere. But I do encourage you not to put it in the chat, because it'll bog the chat down. And also we want to keep the chat spoiler free, so that everyone has a chance to work on it on their own. All right, now I'll ask a great question. They are put in easier to hard order, right? Kind of, yeah, but kind of not, because everyone has their own strengths. I will say that the questions are ordered from least advanced mathematical concepts to most advanced mathematical concepts. But in the middle, you kind of get some weird wiggle room, right? Because if you're someone who has been in like pre-calculus or trig, and you know sine or cosine or something like that, that's an advanced mathematical concept. But a question that like gives you a triangle and says, hey, find the sine of this, could be really, really quick and easy for you. Geometry, we learned that earlier. So geometry is technically considered a lower advanced concept, but a multi-step geometry problem could be a lot harder personally to do. So yes, they do tend to go in increasing complexity. Whether that translates into completely into difficulty for you is not as clear. And so you will, in fact, most likely want to skip around on the math test on the ACT. So you're going to skip over questions, bubble in an answer, and come back to them. Even those that are doable, because you want to do those easy for you questions first. Okay, I am going to give you a little bit of time to try this one on your own. And as guest 9202 asks, is this session more tips and tricks, or are we going to do a more rigorous section? It's going to be a bit of both. It's definitely going to talk about some strategy that I really want you to take away, but we'll also be looking at some of the kind of content areas that you must know for testing. All right, let's take a look at this question right here. I'll give you a minute to think about it. Okay, so I didn't quite give you a full minute for this one, because like I said, this one might be one that like you don't need a whole lot of time to work on it. But here's what I do want to ask you. Tell me in the chat, what is this question asking you to find? Because we have a pretty straightforward linear equation here, not even a linear equation, we just has an algebraic equation. And our gut is just to say solve for x. Okay, so I'm going to subtract 7 from both sides. I'm going to divide both sides by 3. Then I'm going to like, sweet, x is 5. And I'm going to come over here and I'm going to bubble answer choice A, right? Because I just solved for x and I did a great job doing that. However, that's not what this question asked for, right? This question wants us to find 2x. Oh my goodness. So this is an example of one of those questions where it can seem very straightforward, but it's also really easy to fall for a wrong answer, not because you didn't understand the math, but because you didn't answer the right question. So we're not going to go for answer choice A. We are in fact going to double it and say that 2x equals 10. And we're going to finish the problem all the way and bubble in answer choice B. So sequence says find x, then double it. Exactly. So what I want to illustrate with this question is not, how to isolate a variable, but always identify what the question is asking you to do first. And in fact, I like to underline those things when I'm doing them. Underline the question first and then do the math, because then when you come back to it, you can ask yourself, okay, did I finish it? Am I done? Did I actually solve for this thing I underlined? And if the answer is no, then you know to do a few more steps. Okay, let's take a look at another expression here, an equation, in fact. So a radical equation. Go ahead and try this one on your own. All right, a couple of you are still working. Some of you bubbled in your answer in the poll, but I'm seeing some questions on calculators. So as you may know, you do get a calculator for every single question for the ACT math test. So you are more than welcome to be using that calculator right now, of course. Now, there are some questions that might be easier to do without a calculator. So the calculator is a tool, but it's kind of like a hammer, just because you have a hammer doesn't mean everything's a nail. Just because you have a calculator doesn't mean every single question you need to use it on. A lot of the questions are designed to be easier, or at least pretty straightforward, without a calculator. Now, Guest 3575 asked a great question. Will the proctor erase your calculator memory? Well, they are within their right to do so, because you are technically, on your honor, supposed to have done that yourself. So even if your proctor doesn't do that, you shouldn't have anything saved. Or if you do have things saved in your calculator, you 100% should not access it, right? Because that is considered cheating if you have, say, like installed some sort of other app or written some program for your calculator that does some things that are outside of the normal functionality of it. So again, will they like literally take your calculator and erase it? I don't know, but whether they do or not should be totally irrelevant, because you shouldn't have any, you won't be accessing any of that, right? Because you don't want to go against the code of conduct that you should for the test. Okay. So let's take a look at this one here. Now, this is we have a radical. And so sometimes the knee-jerk reaction here is just to square both sides right away. The problem with doing that is if you square something that is added or subtracted, like we see here, we have a binomial, right? The square root of 2x minus 5 isn't a single term, it's two terms, in this case, subtracted. If we were to square this whole side, the whole left side of the equation, what we wouldn't get is root 2x squared minus 5 squared, right? We'd actually have to FOIL it out, because if we think about it, if we were to put parentheses around this whole side and then square the whole thing, that would be like squaring a binomial, right? We'd have to FOIL it out. So instead, what we have to do when you see a radical in an algebraic expression is to first isolate the radical. So the first thing you're going to do is get the radical all by itself. So we're going to add 5 to both sides, and we've done it. Now that we have the radical all alone on the left side of the equation, now we can square both sides, because now when we square both sides, we do get the radical just all by itself squared. So the radical sign goes away. So we just get 2x on the left, and of course we can square 6 and get 36. Divide both sides by 2, and we get x equals 18. So that would be our answer here, answer choice E. Now, Angelica asked a great question. Wouldn't the answer be plus or minus 18 because there is a square root? Good question. So think about what would happen if you plugged negative 18 back into the original equation. So in this case, if we plugged negative 18 back in there, we'd have the square root of negative 36. And the square root of negative 36 is going to be a very different thing than the square root of 36. So when you are solving for a variable under the radical, it's very likely you're always going to get something positive on this end. But you can always double check for extraneous solutions by plugging them back up under the radical and seeing if they give you a real solution or not. Because in this case, if we plugged in negative 18, we'd end up with an imaginary number because the square root of negative 36 isn't going to exist. So great question. I am glad you asked that. Now, Isabel asked another question. Why is the 5 included in the radical when the radical doesn't come up? Oh, it's not. So in this case, the 5 is not included in the radical. So the first step we had to do was, in fact, add 5 to both sides to, in fact, isolate the radical all by itself. Because you're right, that 5 is not part of the radical at all. And that's why it would be so problematic if we squared both sides right away. Because then we wouldn't be squaring a radical, we'd be squaring a binomial, and we'd have to FOIL it out. There's some really good questions coming in on these. Let's look at another one. Guess 5976 says, what's the best advice for these tricky word problems? Well, I don't know if this is a tricky word problem, but it is more of a word problem than what we've seen so far. I'm going to show you a wordier word problem in just a minute. One of the things I would say when you see something that looks, if it looks overwhelming, first step is, remember, you can choose to do things in a different order. So if a question looks intimidating, you can always skip over it and come back to it. Many people have kind of this ingrained sense that, like, if you skip over a question, that somehow like giving up or somehow a failure or somehow quitting, because we've been accustomed to tests in school where it's like a perfect, like 100% is the only thing that matters, right? You got to do all the questions. The ACT is a very different test. You want to try to get as many questions right as you possibly can within the time limit. And so because that's a very different goal than do all the questions always, you want to make sure you're doing those that are easier for you and more straightforward for you first. All right, so go ahead and take a look at this one. Give it a go. Vote in the poll when you've got it. So see a couple of you asking about the breakdown of geometry versus algebra. You're going to see both of them fairly often on the ACT. About a third, a little less than a third of the test is going to be geometry. The rest of it will be coming from algebraic concepts. Now, you also do have a couple miscellaneous topics in there, but the vast majority of it is going to be algebra. All right, so let's take a look at this one now. And first, it looks like we have a lot going on. We have multiple variables. We have an A, we have an X. Oh, what are we gonna do? The great thing about it is we know that if we have two variables, we need two equations. The thing is we actually have a second equation. It's this right here. It's X equals 3. That's still a second equation. That's actually a really nice equation. So this question just requires us to substitute in. We're just gonna substitute 3 in for X. And as soon as we do that, everything is going to be in one variable. Now we only have A to deal with. So as soon as we substituted in 3, we just have to combine like terms and now isolate A. We're going to subtract 9 from both sides and divide both sides by 3, and A equals -1. We're going to go ahead and grab answer choice H. I was going to highlight what guest 6558 says. These moderators are doing a great job. I am so glad you feel that way. I know sometimes it can be frustrating when there's a moderated chat, but really it is so that your questions come through, so that we can see your questions, and so that your questions can get answered, and that you can see the questions of others to know that you were the only one with that question, in fact, as opposed to just having, just like words go everywhere because of all the chats that are coming. Now, L asks, are matrices on the ACT? L, they could be, but it's really, really rare. Like we're talking maybe you'll see one question sometimes, and sometimes you'll see none. So matrices show up between 0 and 1 questions on the ACT. So I'll let you decide whether that's worth spending a lot of time reviewing and studying or not. For most people, the answer is going to be, it's not going to be worth a lot of your time to focus on. But for some of you who are, already feeling very, very comfortable with the majority of the material, the matrices might be something that you brush up on a little bit because you might see it. But it's definitely not one of the, major must know topics in order to reach your goal. Okay. Now, guess 6846 says, what should we do if we come across, let me get my tongue in order here. What should we do if we come across a problem we don't know how to do? I have a very easy answer for that one. Skip it. Bubble in a guess and move on. That is, in fact, not giving up. That is the smartest, most strategic thing you can possibly do. And if there's one thing you take away from this hour with us, I hope it's that. If you don't know how to do something, or if a question is looking intimidating, guess and move on. Don't waste your time on it. Don't, get all demoralized. Be like, oh my gosh, everything is like the worst because I can't do question number 19. Just be like, question number 19, you're not worth my time. I'm going to spend my time on question 20 and 24 and 26 and 29 and all these others I know how to do. And you know what? If I get all of them done, I can come back and look at you. But if not, like, you're really just not worth my time. Question number 19, and bubble in a guess, move on with your life. Don't let it get you down. There is not a single question on the ACT that is worth becoming test day quicksand. There is not a single question on the ACT that is worth more than the other questions. So do the ones that are easier for you first. Do the ones that are doable, but maybe time consuming second. And then if you have time, look at the others, because at that point, if you didn't know how to do them, then they're just bonus questions if you can sort of figure it out. And that's how you want to tackle it. All right, here's one of our wordier word problems. So I know there was a question like, how do we deal with these wordier word problems? So one of the ways to deal with it is, in fact, to go straight to the end. The reason word problems tend to become overwhelming really quickly is because if you start reading up here at the very beginning, which, is it safe to say most of us start reading at the beginning? If you start reading up there, the information you're getting, you don't really know what to do with it. You're like, okay, blah, 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 backstory, number, more backstory, number, more information, what do I do? Information overload. And then you get to the question. And you're like, oh, that's what I have to do. Okay, now you got to go back and go find all the stuff that you need to do the thing that now you know you need to do. So you can circumvent that entire waste of time and instead go to the end. Identify the question first, just like we did in that first problem. Now in that question, the question was like 2x equals. So it's really easy to identify it. In a word problem, you just have to go to the end. It's usually the very last sentence or the second to last sentence if the last sentence is like round. So in this case, we just want to know, what is the slope of the ramp? What's the slope of the ramp? And now we have turned this word problem into something much more straightforward. Because at this point, we just have to go back and see, well, what information do I need to figure out slope? We don't care about so much of the information that's here in this problem. We don't care that this is about like building inspectors, blueprints, blah, blah. Like, we don't have time for that. No one's got time for that on test day. What we do care about is that the ramp goes through 2 points, this point and that point. And so once we know we have 2 points, we can just find the slope. And we can find the slope using the slope formula, right? y2 minus y1 over x2 minus x1. You may also know this as rise over run or change in y over change in x. It doesn't really matter how you think of it. Maybe you're in calculus and you think of this as like f of b minus f of a over b minus a. That's fine too. All you need is a way to calculate slope. And we've got 2 points. We've got a formula. We're just going to plug it and chug it. And the one thing we are going to pay attention to is subtraction of a negative. Because either way you put these in, you'll have to deal with a negative sign. So watch the sign. But there we go. 5 over 13 matches up with an answer choice. And that is answer choice D. Now, Lauren has a great question. What are some tips for eliminating careless errors? I usually make mistakes being careless. Lauren, you are not alone. And interestingly enough, I find that a lot of careless mistakes are in fact made not most often, but much more often by those who may feel very confident in math. So it's not that you're making careless mistakes because you're bad at math. You're actually quite good at math and you feel very confident doing the math you're doing. And that's in fact why the mistakes are being made, because you're moving just a touch too quickly and making a touch too many assumptions because you've seen a lot of math, you've done a lot of math, you know what to do, and you kind of do it. And sometimes don't answer the question all the way, or sometimes make a silly mistake because you're moving just a tiny bit too fast. So if you are in that boat, if you're like, man, I look over the reasons I got a question wrong and like I'm missing questions I knew how to do. One of the things to do is, going back to what I mentioned earlier, is doing the questions in order of difficulty for you. So particularly if you're finding that you're making mistakes because you're rushing, then rearranging the order that you do questions really helps with that a lot. Because what you're doing is, rather than doing one question that took you a little bit longer, than being like, oh my gosh, I don't have any time anymore. And then now you're like panicked as you do a question that might have been really easy for you. So you make a mistake because you're rushing. If you do the easy ones first, well, you got plenty of time left. So you're feeling good, you're feeling comfortable, you don't have to rush. Then you're doing all the ones that take a little bit longer, but like, you know that they're all going to take a little bit longer at that point. So you don't have to freak out if they do take you longer because you expect them to. So that can be one big thing. And the other is, as you're practicing, make note of the types of mistakes you're making. So for instance, if the silly mistakes you're making are like forgetting to distribute negative signs, then anytime you see a negative sign, just treat it like a big yield sign and be like, okay, this is where I need to, don't make the mistake again. Don't do it. Don't do it, self. So that's going to be the other thing, is if you find yourself making silly mistakes, keep a why I missed it journal, or keep a little like a why I missed it record, and notice those trends. What type of mistakes are you making? Once you know what the problem is, you can much more easily fix it. Okay, let's do another one. This one's also asking about slope, but it's asking us about slope in a very different way. So I'm going to have you try this one on your own and go ahead and vote in the poll when you got it. Okay, now if some of you are thinking, I don't think that was quite a minute, in fact. Some of you might be feeling a little bit like Julianne mentioned, which says, she says, it's funny, minutes are actually a lot longer than they seem. I was timed, I thought it was a minute after 15 seconds. Yeah, when we're in a timed environment, time like both simultaneously expands and contracts. Like it expands at the problem level, like every problem seems like you're working on it forever. But it contracts, and then like every problem's like, it feels like there's like never enough time. So I kind of want to go back, since we are talking a little about time here, to a question from one of, I forget which guest you were, I apologize, guest, which was, how long is too long to spend on a problem? When it's unproductive work, then that's when it's too long. So if you're doing the questions in order that are the right order for you, which is like you're doing the ones you know how to do first, so they're not taking you very long because you know how to do them. When you work on a problem and you realize you don't quite know what to do next, or you're thinking about it, you're not sure what the next step is, move on. That's when you guess and move on to the next question. So that's unproductive time. You want to spend the time you need on a question to get it right. And if you do the questions in the right order for yourself, then that's going to maximize your score. What you don't want to do is waste time. And wasted time is when it's no longer productive, right? That's when you're like looking at a problem, you don't know what to do. It's causing more stress and panic, and it's not actually moving you forward. That's when it's time to skip and move on. Now, this question asks us about slope. We want to be careful that we're not just like, oh, slope, look at the coefficient in front of the x. because this is actually not in point slope or slope intercept form. So we're gonna have to put this in intercept form first. So to do that, we're gonna have to subtract 8x from both sides. We're gonna have to divide both sides by 9. So this is what this equation looks like when we put it in slope intercept form. And now we're asked for the line parallel. Well, parallel lines have the same slope. So we just had to grab what the slope was once we put it in slope intercept form, and our answer here is G. Now this could have also asked you for the perpendicular slope, where you would have had to flip it and switch it. So perpendicular would have been positive 9/8. They were very nice. This question does not have that as a wrong answer option, but 8 is definitely a wrong answer option. And that could be one you might have made if you didn't double check to notice that this wasn't in slope intercept form first. Okay. Now, a couple of you did want to talk a little bit about trigonometry and geometry. So let's take a look at one of these questions here. This question is asking us about tangent B. Now, for those of you who have not done trigonometry yet in your classes, one thing I do want to point out is that you can answer almost every single question of trig on the ACT using SOHCAHTOA. So that's the acronym that's going to be very helpful for you. And trig is just showing a relationship between different sides relative to an angle. So tangent, I'd say you can go ahead and put it in the chat. There's a lot of us here, but so we'll probably get a lot of those chats. But tangent B, we're going to have our reference angle here is B, and we're going to need to find the sides that tell us what that is. So this is tangent theta. I guess we should have said tangent B. But tangent in general is opposite over adjacent. That's the TOA of SOHCAHTOA. Tangent, opposite, over adjacent, TOA, TOA. Opposite meaning the side opposite the angle, this one, and the side adjacent or touching the angle, this one. So once we know that, we can say, all right, that means tangent B is going to be X, the side I don't really have, over 2, CB. That's the adjacent side. Now, many of you may be good at this point, but then it comes into, well, what is X? It's a trick question. What do I have to do? One of the things that I love about this is you can use a lot of process of elimination. Even if the only thing you know about trig is that tangent is opposite over adjacent, look at the, you know, the adjacent side is not 5, right? Because 5 of any triangle is a hypotenuse. Can't be K, can't be J, can't be H. So even if you just knew, like, this is a hypotenuse, if you know that SOHCAHTOA acronym, you can get rid of 60% of your answer choices just like that. Now, we have to figure out what X is, but that's okay. We have a right triangle. You don't have to be in trig or have taken trig to know this. Tell me in the chat, how do you solve for a side of a right triangle? And if you're thinking it is the Pythagorean theorem, you are absolutely right. So we're going to use Pythagorean theorem, a squared plus b squared equals c squared, and we're going to be able to solve for that missing side. So 5 is the hypotenuse, 2 is the other side, and we can solve for x. X is root 21. There we go. We just have to combine it. Root 21 over 2 is answer choice F. Now, this was a really quick review, so if you hadn't seen trig before, don't despair. Just make a note to look up SOHCAHTOA, because that tells you what the fraction is that you need for those relationships. And I see several of you have put it in the chat. Fantastic. SOHCAHTOA. Now, here is going to be our last question. Neil says, remember the teachings of the Greek philosopher Pythagoras related to the other one. You know, true story, my math teacher all throughout high school had pictures of all of the mathematicians of the ages, and Pythagoras definitely featured prominently. That was the one that got put on the front of his desk. So everyone else got like wrapped around the room near the ceiling, but Pythagoras was up there where we could all see his face every day, or I guess what historians think his face looks like. Okay, let's look at circles. So we want to know which of the following is the equation of a circle. Well, this requires us to know the general equation of a circle on the coordinate plane. And once we know what the general equation looks like, we're going to be able to do a pretty good job of eliminating some answer choices here. So if you know the equation of a circle, awesome. If you don't, here it is. So our general equation of a circle on the coordinate plane is x minus h quantity squared plus y minus k quantity squared equals r squared, where r is the radius and h comma k is the center of the circle. So if we think about this, here's our circle. It says it's tangent to y. This just means that it's touching there perfectly one little spot. And what that enables you to do is figure out what the radius of the circle is. So if 4 is right here, and I'm on the x-axis, we also know what the center of our circle is. So go ahead and tell me in the chat, what is the center of our circle? What is the radius of our circle? And as you're doing that, I guess 6846 asks a great question. How do we remember that's the equation to a circle? Well, here's a good way to remember equations for anything. There's kind of 3 ways to remember stuff, and it's really going to depend on which way of memorizing works better for you. So I'm sure a lot of you already know about flashcards. And if you're someone who knows about flashcards and likes flashcards and flashcards work for you, then make a flashcard. Some of you might know about flashcards and say, but I don't like flashcards and flashcards don't work for me. I'll be honest, I'm not a good flashcard learner. I do not memorize stuff very well, but looking at flashcards, it doesn't help. But the way I learned all the formulas that I had to when I was in college is I would write them out. So if you have a whiteboard or you have some scratch paper, the first couple times you just copy the formula down. Copy it down 10 times. And then by the time you get to the 10th time, maybe you can start to do it a little bit easier. Next day, do it again. Write it down 10 times, and eventually you'll be able to write it down from memory. That's another way to memorize formulas. And the third way, if neither of those work for you, is to record yourself saying it aloud and then listening to it. So some people memorize things very well by listening. Again, I'm not that type of person myself, but you might be. So flashcards, writing it down, or recording yourself saying it and listening back. Those are 3 really good ways to memorize formulas. One of those ways will work for you. I do not know which one it's going to be, but one of those ways will help you memorize formulas better. Okay, so here is our radius. Our radius is 4. And the center of our circle is 4, 0. Well, just knowing the radius is 4 eliminates 2 of our answer choices, because I don't want the radius. I want the radius squared. So A out of there, D out of there. And now I'm just plugging in 4 for H, and I'm plugging in 0 for K, and matching it up with an answer choice. So if we have the general equation of a circle, and we know the center and the radius, all we gotta do is plug it in and match it up with a choice, and that matches up with answer choice B. Work on this one. That's going to be our last math question, but really good questions coming in so far. Keep them coming. I do want to make sure we have time to talk about science as well. Now, the science test is the very last test on the ACT, and for many that makes it doubly difficult because you're already feeling a little bit of test fatigue. It also moves quite quickly, 35 minutes long and 6 passages. What I want to focus on here is if you've ever thought, man, I just don't have time to read all 6 passages and answer all those questions, don't. Do not read the passages. Just don't do it. It's not that you personally don't have time to read all of the passages and answer the questions. Nobody does. I don't. Laura doesn't. Nobody does. David doesn't. Like, there's just not enough time to read all the passages and do the questions. But the great thing about it is most of the information you need, if not all of the information you need, isn't going to come from the text. It's going to come from the charts and graphs and figures. So what you want to do when you see the data type passages, these are the ones that are mostly charts and graphs and figures. Even when you see the one that has experiments but charts and graphs, you still want to just focus on what are the variables. What are the variables? What are the variables? And if you know that, you can go to the questions, and the questions will guide you to whatever else you might need in the passage, which could be anything from nothing to a little bit that's close to nothing. You're not going to need very much information from the passage itself. It's almost all going to come, like 90% is going to come from the charts and graphs and figures, with the exception of the one multiple conflicting hypothesis passage. But that one you can identify because it doesn't really have any charts and figures. So what you want to do is focus on the independent variable. What are the dependent variables? What are the controlled variables? Al says, do you really never read the passage? Really, Al, when I'm looking at science passages, I do not read the passage. I only read the conflicting viewpoints passage. Otherwise, I go and I look and I say, what are the variables? What's the independent variable? What's the dependent variable? And then you move on to the questions, because all that other stuff is not going to be needed. And you know what? If there's a question that does ask about something else, then you can go and look for it. But it's very, very, very different than reading. With reading, you need to read the stuff. With science, you don't. It's all about the variables, and it's all about what's in the charts and graphs and figures. Okay. So our independent variables, these are the things that the experimenter, the scientist, has control over. Yeah. So where do you tend to find the independent variables on a graph? Where do you tend to find the factor that's being changed on a graph or on a table? So if it's a graph, we're typically going to find these on the x-axis. We're typically going to find these on the very left-hand columns of tables. There's also going to be a sentence in the text that says this too, but like, why sift through the passage if you can just look at the graph and look at the table and figure it out instead? And then we're going to look for the dependent variable. Now, the dependent variable is what is being measured, right? So it is what changes because of the independent variable. It depends on the independent variable. It is being measured. So I like to say independent variable is manipulated and the dependent variable is measured. It's often on the y-axis. It's on the right-hand columns of a table. And the controlled variable, this is everything else. So if it's not independent and it's not dependent, it's going to be a controlled variable. Now, in that experimental passage on test day, all of the different experiments are going to have the method, and all that other stuff is going to be a constant. But if it's not an independent or dependent variable, it's a constant anyway. So you don't need to worry about it. If it's not one of the two variables that count, it's a constant. You can just safely make that assumption. I guess 432 says, the passages are so boring anyway. Well, good news for you. You can just skip over them, and in fact, better. To that effect, we've cherry picked some questions here without the passage at all, just to illustrate that these are actual ACT questions, and there's not even a passage that we put on the screen because you didn't even need it. And we could have picked like so many other questions. We just happened to pick this one or these. But notice how like there's no passage. Guess what? You're going to be just fine. Now, Osvaldo says sometimes a question secretly refers to the passage. Sometimes, yep. And you'll know that's the case when you get a question and you're like, I think I need a little bit more on this one. And when you feel that, when you're like, I think I need a little bit more, go get some more. It's not like you can't look at the passage. I'm not saying, like don't look at it if you need to. What I'm saying is don't just like read it on autopilot. Don't just knee-jerk reaction, read the passage. Go identify the variables, go to the questions, and then if you need to reference the passage, by all means do, but just don't make reading it like the first step you do just to have read it. Okay, so let's take a look at this one. We want to know which of the following solutes shows the greatest increase in solubility as the temperature increases from 0 to 100. So we're going to go ahead. We're going to assume this is part of a passage. Let's figure out what the variables are. What is the independent variable or variables? What is the dependent variable or variables? Well, independent variable, we are going to look on the x-axis. Temperature is our independent variable. Dependent variable, we're going to look on the y-axis. Solubility in grams of solute per 100 grams of water. That is our dependent variable. But then we also have all these things over here. What are all these? Are they independent or dependent? And in fact, this is an example of a table where we actually, or I'm sorry, this is a figure, not a table. This is a chart where we actually have two independent variables. We have temperature and we have the solute. Now, this is where I think Evan and Athoto have said, well, but some of the text gives us context. It absolutely does. So like in this passage, solute would have described these. So if you weren't sure, like you could go back and be like, ah, yes, these are solutes, and that would have helped you. But, so it's there if you need it. So we can see here that we want to know what shows the greatest increase. I'm looking down here at our poll. A lot of you are feeling that the one that shows the greatest increase is the one that goes from 0 to a lot really fast. It is our, I like this, sunny potassium nitrate. Or if you don't know the chemistry, because guess what? You don't know. You can just be like, it's the Cano. It's the Cano 3 that does it. Boom, grab it, answer choice D. You do not need to have advanced science knowledge of any topic. So whatever you took as a freshman, which is likely to be some integrated science or general science, that is the science that you need to know for the test. All right, let's take a look at this next one. Which has a lower solubility at higher temperatures? We've already looked at the graph. So all we have to do now is figure out, well, lower solubility at higher temperatures will look like what? Now, I guess 6558 has a great question. What does solubility mean? And I could answer that, and I will. I'm not going to leave you hanging here. But I do want to point out that it is completely irrelevant whether you know what the word solubility means to answer this question correctly. Totally irrelevant. This word could be anything. This one could be which has the lower elephantabulism at higher temperatures? And you'd go over here and be like, oh my gosh, elephantabulism is the y-axis. So I'm just looking to see, when does the y point go down as temperature go up? So don't worry about the concept itself. I think that's what a lot of people get wrong, is they overthink the science test. Just look at the units, match it up. Now, what does solubility actually mean? Solubility is how much you can dissolve something in a liquid. And so in this case, we're looking at how many grams of each of these things, these chemical compounds, can we dissolve in water? That's what's actually happening here. But if you didn't know that, you could still get this question 100% right without ever knowing what the term means. So we want to know which have a lower solubility. So which of these are going down as temperature goes up? Well, we just have to kind of look and be like, we don't even have to think about bromides, nitrates, sulfates, chlorides. Let's not get ahead of ourselves, because it tells us what each of those contain. So sugar's going up. No. Cano is going up. NaNO3 is going up. This one's going up. That one's going up. KCl is going up. Okay, this one's going down. And this one's going down. Done. Okay, those are the two that are going down. They both have an SO4. So it looks like it's the sulfates that go down, the Y values go down when the temperature goes up. Okay, now let's take a look at a table. We've seen a couple of graphs here. Let's look at this table. The results of the two experiments. Okay, so this one had experiments. We haven't read them. Oh well. Support the conclusion that for a given brand of tape, brand, as the tape width increases, okay, it increases as we go down, okay. The force does what? Well, let us break it up. Let's look at tape X. For tape X, as my tape width increases, I'm looking down. I'm putting them in order that way. So if I go over here and look at my average force, looks like it follows the same trend. As width goes down, average increases. Let's look at tape Y. Okay, same thing. Okay, this gets bigger as I go down. So if I look at its average, oh, it also increases. So they both increase, and it's going to be answer choice F. So again, don't overthink it. Don't let the fact that don't let the fact that there's got a lot of stuff going on in the tables, don't let that be what gets in your way of rocking out your science score. Just break it down one step at a time. And notice we've now done 3 questions. There have been no passages in sight. Okay. Now I saw a question earlier, so I want to put a pin in this one from Lauren, which asked about the Conflicting Viewpoints passage. We'll mention that at the end, but I'm going to put a pin in that because that's one of your 6 passages. So that's actually the least bit of science you're going to see. Okay, let's look at this one. Whew, this is a pretty complicated figure. We got all sorts of stuff going on. So what I want you to do is I want you to try to break this one down. Don't overthink it. Don't overcomplicate it. Look at the question. Look at the answer choices that you're given. Try to break it down one piece at a time. Okay, let's take a look at this one. Coordinate figure 4, which has like all the things going on. A facies G rock, whatever that is, will most likely form under which of the following pressure and temperature conditions? Now, what's cool about this graph, which is not actually what's needed to answer this question at all, but I do want to point out, this is one of those rare figures that actually has a lot of variables. It's got temperature on the x-axis, but it also has pressure and depth, and all of these are independent variables. It's almost like a phase change diagram. So this is kind of a unique one. We just want to make sure, like, where do all these things intersect? Because what's actually being measured here is what type of rock we have. We want to know, like, what's going to give us a facies G. So if I put in this and this and that, I'm going to get a facies G rock. So what are my facies G ingredients here? Guess 23 says, Stephanie, you rock like a facies G rock. Is that working? Okay, so let's take a look. We want to know facies G. Facies G is right here. So there's two ways we could go about this. One is that we could think about the conditions that are making it. We could look at the pressure, we could look at the temperature ranges, or we could use the answer choices. And we could say, okay, well, when the pressure is 3, okay, that's up here. Well, like, there's no facies G up there. Okay, no. If the pressure is 5, no. If the pressure is 8, no. So we don't get facies G until the pressure is bigger than 10. There's only one answer choice that we even have to test. When the pressure is 11 and the temperature is 600, look at that. Boom, right in facies G territory. Gotta be answer choice D. Now, the cool thing about this is that, these are actual ACT questions, right? So this is not like just some convenient question that looked really hard, but then ended up being very doable. They're doable. Just take it one step at a time. And Alexa says, well, I thought there was a lot of science vocab. I mean, technically there is. Pressure, temperature, facies, G-rock, whatever that is. These things are all scientific terms. Don't let the terminology get in your way of knowing how to read a graph, right? If you see a technical term that you're not sure of, make it a prettier word. Just use the first letter. Just be like, and the M. Okay, where's the M? Like, where do you find it? It's like, you don't have to know the terms. You don't have to know what they are. So don't let that get in your way. Don't let that make you lose confidence, because often what happens is you're not expected to know the science. You're not expected to know all of these concepts. Someone asks, is there biology? Yes, biology, earth science, physics, chemistry, biology, astronomy, all of those could be things. You're not expected to be experts in any of that content. What you are expected to be an expert in, or that you're showing mastery of, is, do you know how independent and dependent variables work? Do you know how to find how a table or a chart or a graph works? That is what you're really being asked. Do you understand how experimental design works? And you do. Right? Because that's one of like the first science classes that you take, is like, what's an independent variable? What's a dependent variable? got to keep things constant, can't change everything around and then compare the data. And that's really what most of these questions are testing. All right, here's our last science question. In fact, our last question of the night. What is the best approximation for the normal boiling point of octane in figure 5? Okay. Well, I've got a lot of anes, pentane, hexane, heptane. Okay, octane's down here. There is my octane. So the first thing I do is to go find it. And then boiling point. Well, we're not expected to have this memorized. So instead, we're going to go and I'm going to see, can I find it on my graph? Where is it? Boiling point of pentane is there. Boiling point of hexane is there. Boiling point of heptane is there. Boiling point of octane is, oh no, it's not on the graph. But that's okay. Because things that aren't shown on the graph, you can figure out with trends. Because what's been happening is going to continue to happen. So I'm actually going to extend this boiling point line. And I'm going to extend my octane line. And now I'm going to look at this, I'm going to say, octane's boiling point is right there. Whatever that is. That's where octane's boiling point is. But I know a couple of things. I know it's greater than 100 because it wasn't shown on the graph. So I can get rid of F and G. And I've seen students work through this question a couple of different ways. One is to notice the trend, that like each of these get about 30 bigger than the next one. So octane would be like 30 bigger than heptane. That's one way to think of the relationship. The other is to say, well, this intersection point here is like yay far away. So how far away is that in terms of the scale? And it's about 20-ish bigger. So it's certainly not 45. It's certainly not like halfway bigger. So we could estimate and say it's going to be around 120, 130-ish. And H is an answer choice that's right there in that range. Now, so this is the part that I mess up a lot. Extend the trends. Whatever trends you have going for you are going to continue. You never have to worry that like somewhere along the way, they're going to give you that one science principle that's like, as soon as you leave the known margins of the graph, like, oh my gosh, it changes so dramatically. They're never going to give you that. Whatever you see with the rest of the data is going to continue. Those trends will always continue. And Blake says, can you draw on the actual exam like how I just did? Well, you can draw on it with one of these, with a pencil. You can't draw on it with like fancy blue and pink highlighters, but you can absolutely draw on it with a pencil. Yes. So with that regard, yes, you should draw, mark all over your test booklet. Absolutely, you can do that. And I encourage all of you to write on your actual exam. Yep, because it's going to be a really, really helpful thing to do. Okay. Well, that was my last question. Oh, I promised I would answer Lauren's question about the conflicting viewpoints. So with that one, that is the one you will actually read. You're going to read it and you're just going to make note of every single, like the point of view for each of the scientists or researchers or whatever. And then you're going to go to the questions. So that one you are going to read, but you're just going to quickly be like, okay, what's this person think? What's that person think? What's this person think? And then once you have that, you'll go to the questions. It's kind of like the science anomaly. It's the oddball. So for some of you who are really strong in reading the conflicting viewpoints, you might do it first. For those of you who are like, don't give me more reading, then maybe you'll do that one last. Okay. Well, so tips for success. Know where you're going, just with anything, just like with a math question. You got to know where you're going in order to start. Know your starting point, know your target score, know where you're going. Think about a personalized study plan. You've got time. Right? There is time between now and the next administration of the ACT. A couple of you are asking, will the ACT in June even happen? That is a good question. Right now, that is unknown. So, you can practice and prepare as if it is. And if it's not, know that ACT and colleges are all aware that those are things that need to be coordinated. So they would add in extra testing dates in order to enable you to have access to an exam date. So even if the June ACT does not happen, know that there will still be options. They'll likely add in some other dates, or there will be availability or opportunities to take the test. We talked about some strategies, practice, review, just like we did here, thinking about why you missed it, right? Keep track of those mistakes so you know how to fix them. Take some practice tests, take some full-length practice tests. We've got some great practice tests that you can access here with us at Kaplan. You can also access some full-length practice tests on act.org and tap sources of expertise. All of you are in fact doing this because you are here, which is amazing. Guest 2883 says, will there be an English reading video like this? There will be. I have got the date. I know I am doing one. I think it's May 5th, but I might have the date wrong. But it is. It's going to be like in a week or two. There will be an English reading video just like this. All right. So if you're unsure where to start, come chat with us about building a study plan. You can make an appointment at youcanbookme.me at Kaplan PC Teacher Talk. As some of you were asking, I saw a question, if does somebody teach other online classes like this? I do. I, along with David and Laura, we are all part of the our ACT team at Kaplan. So we do all of our online ACT courses, not just like this, but with people just like us, going through this. So I'm glad you all got something out of this. Thinking a couple other final questions here, but I think a lot of you say thank you for doing this. Well, thank you for being here. You are putting in the effort. You are being in the right place. We're definitely tapping expertise and resources available for you. Thank you so much for an awesome session. I wish you all the best. Have a great rest of your night, a great weekend, and best of luck as you pursue your college dreams.